Hello, this is Nitin Dahad with the Times. I'm here at SEMICON West with Applied Materials and the president of the Semiconductor Products Group, Prabu Raja. Hello, Prabu, how are you?
Pretty good. How are you?
I'm fine. I believe you have a very strong reputation in the industry. Customers like to talk to you, don't they?
Well, I travel a lot to see customers and particularly get increasingly more these days. And part of the reason is the technology is getting more complex.
Exactly.
And the customer want to work with us closely.
Yeah. So I mean, that's what I was going to come to. Basically, the pitch today that you've done at the conference here is all about the complexity and how things have been changing in terms of the relationship with the customer. I'm not asking you to name customers, but where in the past they'll come with a spec and tools, and now it's very different. They have to say, well, we've got this challenge, that challenge. How have things changed, and what makes the world different for Applied Materials?
I think, again, go back to this artificial intelligence and energy efficient compute.
Yeah.
And what is happening with energy efficient compute? You got to improve 10,000x in next 15 years. So the devices, technologies which are driving it, advanced logic, advanced packaging, DRAM, HBM DRAM, these are the driving force can make it happen right now. What is happening underneath that is the big architectural inflections in every device technology. For example, logic. It's going to gate all around, backside power. DRAM goes to HBM and 4F square, 6F square. And packaging, a lot more inflections happening in parallel. Every one of these technologies, when you look at those, everything is going in third dimensions. What does 3D means? Traditional scaling is, intrinsic scaling is litho etch.
Yes.
Right now it's going to 3D. When you do 3D, a lot more materials engineering.
Yeah.
So that is very complex right now. So what is happening with the 3D structures? Like, let's take a gate-all-around for an example. It takes more than 2,000 steps to do the 2 nanometers. Transistor alone, 500 steps. You think about complexity, I would think about two kinds of complexities. One, if you really look at how you build a transistor, how you build a gate, it is between the nano seeds, you see the fingers coming out, nano seeds, there's a 10 nanometer spacing. We got to put 5 or 6 different materials, maybe 7 or 8 different process into the nano small space.
Yeah.
That means these materials are 1 nanometer thickness. Every angstrom matters. Every angstrom matters.
Yeah.
So the films, now you look at the materials, the bulk properties don't work. Now you are talking about thin materials. That material properties are different. And we are talking about multiple materials. The interface makes a difference.
Yes.
So basically the simple message is interface properties dominate over the material properties itself. Number.
Yeah.
Yes, go ahead.
No, go on.
And the other one is every angstrom matters.
That's a good headline.
Every angstrom matters.
Yeah.
Think about that, taking this complexity of every angstrom matters. You got to run at an industrial scale. The way I think about this is 1 angstrom, you think about how many transistors in a die, how many dies in a wafer, how many wafers in a fab, and multiple fabs. Every angstrom matters. When we calculated, it is at 10 to 20 times. Every angstrom matters, 10 to 20 times, you got to repeat.
Yeah.
So analogy always I give is that about 10 to 20, not the stars. I can't count that. You walk into the beach, every sand grain, imagine everything should be 1 angstrom control.
Yeah.
That's the complexity we are talking about now.
And I think one of the slides you had, I think you showed there's like 117 chips in one package, isn't there?
Yes.
And so sometimes that gets so complex as well. So the bonding, the packaging, everything.
The complexity is not just in a front end.
Yeah.
Right now, you got to connect 2 chips
Yeah.
or multiple chips. So you got to connect those chips in a system right now. The package one system right now, the chip, has 117 chips inside.
Yeah.
You got to connect 10 million connections at the same time. That is getting increasingly complex right now. All the complexity we saw that on wafer, inside those wafer dies, right now is moving to the packaging area right now.
Yeah. It's a big thing. So what's the future? What's the future now? I mean, what do you see?
I think the future, what I see that is the 2 things. One, I talked about Angstrom level control, and what I did not talk much about is the step-to-step interactions.
Yeah.
One step interacting with the steps, neighboring step, or even after 1,000 steps sometimes.
Yeah.
So these process technologies need to be co-optimized. In some cases, they need to be integrated into the one systems. So I see that more and more co-optimization between the technologies, and these or some of the steps need to be integrated into the one tool. That is going up a lot right now.
Yeah. Well, I'd love to talk to you more, but I know you're a busy man. So, Prabu, thank you very much, and I'm sure we'll be talking to you again
Thank you.
quite soon.
Thank you.
Thank you.